streaming.
We are almost completely done with fossil fuels. We have 2 short study goals. They just have a couple of words. We still need to do study goals 27 and 28. I'd like to point out, if you hadn't noticed, we've lectured and taken notes and done drawings or seen slideshows about every single vocab term and study goal in assignment 6.3. Fossil fuels are really important for you politically, for your personal economic global future, and for the AP test. Study goal 27 says, what are some ways to clean up coal? Is that the right one, 27? And when we're trying to clean up coal, please look up. The main impurity we're talking about is sulfur oxides. Does everyone know that X means integers in algebra? Like a 1 or a 2 or a 3 or a 4? So SOx is a chemistry term for sulfur oxides plural, like SO1, SO2, SO3, SO4. So if you had to write the word, this is sulfur oxides with an S because that's the different oxides of sulfur. I'll be doing this a lot in units. So this might be the right time to make a little note somewhere about what SOx means. There are various sulfur oxides, and that's the primary pollution that we're worried about with coal. Does anybody remember how many people died in London in a 4-day period in 1952?
4,000.
That was from smog caused by SOx. SOx is the main ingredient in the coal smog or gray smog. Today, Beijing and Shanghai have really hazardous air quality because of SOx making smog. Smoke and fog that includes SOx. If you've ever heard of acid rain, a problem that was kind of extra scary in the 1980s. Acid rain is all about SOx mixing with water, and the main source of SOx is coal. So in number 27, where it says, how do we clean up coal? The real question is how, by clean up, we mean how do we get rid of the SOx? Your book had 4 ways. I'll briefly paraphrase, but you should get notes from your book. Make yourself a note. I am not going to read you the textbook, but I think you can get it out of there. 4 ways to remove sulfur oxides. You can wash the coal. It's called clean coal or low sulfur coal. So you do like chemical bath and you like soak the coal. So it washes out the sulfur. Low sulfur or washed coal. Means it's been reacted to remove some amount of the sulfur. Option number 2, you can make really high-tech burners in the power plant. You can like add gases to react with the sulfur so it doesn't go up into the air. So they're like fancy burners. And again, your book has a lot of words. I don't want to read the whole book. Option number 3, you can scrub the smoke. It means to mix water into the smoke. It's called scrubbing or scrubbers, where you just wash the SOx out of the smoke. This will come up later in the book, so for now I just want you to have the vocab. Your book has a little bit of notes on that. In a future unit, we'll describe scrubbing more. But basically, you burn the coal, take all the smoke, and where it leaves in a big pipe, you literally run shower heads over the smoke. And believe it or not, that gets rid of the SOx. SOx reacts with water to make sulfuric acid if you're a chemistry nerd. So you can collect all the SOx in the form of sulfuric acid by washing the smoke. That's called scrubbing. Option number 4, you can gasify the coal. Which is like it sounds, you just turn it into a gas. To be perfectly honest, I'm not really clear on how that works. Sorry, I wish I knew more. I think if you make it into a really fine powder and then you preheat it, some of the different ingredients in the coal turn into gas, so you can make like natural gas out of the coal. I don't really get how that works. People call it syngas because it's synthetic gas, gasify coal. In number 27, is it? 27? Is it 27? This is coal one? This is 20? There's 2 problems. Number 1, anything that you do to clean up coal is super expensive. Like super expensive. Like not competitive expensive. All these options are possible. And if you try to compete with other electricity sources, it's too expensive and you can't compete. Problem number 2 that all these have is they don't do anything about the carbon dioxide. We're still causing tremendous climate change when we burn coal. So the 2 inevitable problems are the cost is really high and the CO2 is still a problem. I would like to stress that pretty much coal is dead. Like it's not viable. Like we can't do coal anymore. Economically, it doesn't make sense. Any other type of electricity is cheaper. Unless we're running old plants that are super nasty. I want to remind you that your book had additional notes on this study goal. Is there anything else we want to talk about number 27? And 28, I can do this really quickly. 28 says, what's allowance trading? I don't think this was in the book, was it? Does anybody know if allowance trading was in the book?
It just said the EPA provides trades in order for polluting. So like it pays on it.
Yeah, so I don't know if that's clear enough to understand, but I can clarify. That's not wrong. But I think you would need more background to make sense of this. Study number 28. As a way to lower pollution, the government gives you a limited permission to pollute. Like you're allowed to fart 2 times today. Limited number. You only get so much. If you don't use that permit, somebody else might want to buy it because they really need it. So if you're already farted twice and you got to fart another one, you're willing to pay somebody else for that. If they're not using it, they get to make money. So think about it. If he's allowed to make a ton of CO2, but he did not use that, and she's already made her ton of CO2, but she wants to keep selling electricity, he's going to have a reward for being clean because he can sell his pollution permit to somebody who needs it. They have a penalty because they had to buy that extra permit to pollute. So you make it profitable to be clean, and you make it a problem to be dirty. As those dirty businesses go out of business, the United States can purchase those permits, so there's less and less pollution being made. By the way, you might have heard of cap and trade. This is the idea of cap and trade. Limited number of permits to pollute. Clean businesses can sell them at a profit. Dirty businesses have to buy them at a cost. So you reward being clean and you penalize being dirty. Okay, yeah. Cool.
Is the permit based on how big the company is, or is it just like a certain allowance for like everyone?
There's different permits for different types of pollution. Usually they're scaled. So the way that they scale it is per unit of production. So for every 1 million kilowatts, this entitles you to 1 ton of SOx or whatever. Anybody else? I am completely done with fossil fuels unless you have a question. Since we've gone over the entire assignment in class, please double check your notes. If you have a question, ask me now. I'm available right now. Assignment 6.3, questions? Going twice, questions in 6.3?
Second way to remove
maybe I can remember. Newer burners. They're high-tech burners. So if you do a lot of chemistry in the process of burning, you can guide chemical reactions that use up the sulfur. So like if you limit all of the oxygen, you get SO1. And SO1 can be mixed with something else to make a crystalline ash that you just disposed of. Something like that. So that they're modern burners that regulate the reactions. I think those are called mixed gas burners, by the way. That might be a good word to know. Yeah, okay.
What's methane hydrate used for?
Methane hydrate is not used for anything. So it's flammable snow. It makes a great snowball fight. And to my knowledge, it has no practical application because you can't make energy out of it because it's too hard to move snow around. You know what I'm saying? Emily?
Yeah.
Are you still available for more picking?
Yeah.
Can I get a bunch of chard and a bunch of kale?
You want chard?
Yeah, and kale, one each.
Yeah, do you have a bag or a bottle?
Yeah, I do. Anybody else on 6.3? Is your hand up? Yeah. Okay. Then take out assignment 6.4, please.
Chard and kale?
Yes, please.
A lot? Put on the camera.
No, not a lot. No one put on camera right there. Don't go on camera.
I just did.
Dang it. Maybe like that much. You need scissors?
Can you take all my scissors?
Vocab at 6.4. Vocab at 6.4. Yeah.
Digestion.
I'm really glad that you asked. Really important, critical, difficult science question. Can you actually light farts? The answer is definitely yes. I have extensive testing experience and a lot of data to draw from. You can light farts. Can you light burps? No, you cannot light burps. there's a reason why when you go burp and you try to light that, that's carbon dioxide, which is not flammable. But when you go, that's methane, which is natural gas, which is flammable. Can anybody explain to me why your burps make CO2 but your farts make methane?
I thought only cow farts make methane.
It's true that cow farts make methane, but human farts also make methane. We should be clear. The majority of burps and farts is just trapped air. So when you like gulp your food, like I'm a gulper, I eat really fast. If I eat like a big ass burrito, it takes me like 7 seconds. Like I just like gulp my food. I was inspired by my uncle when I was a little boy. I remember looking up at him and he would eat just these like slabs of steak in one bite. And I was like, that guy's so manly. And so I don't know why, but I've been gulping my food ever since I was a little boy. So, of course, I burp a lot and I fart a lot. And most of that is just trapped air. You just ate a big pocket of air. But you also eat carbon compounds, and those carbon compounds are broken, they're digested. Why do you burp CO2 but you fart methane? This is actually important. You're going to need this for your notes. Why do you burp CO2 but you fart methane? I can give you a hint about the human body. Watch. Or rather, listen. Listen. Have you ever been like snuggling on another human being and you've heard them move and in their body you hear this sound? Yes? I'm big on back scratches. So I sleep on my wife's stomach. I used to do that with my aunt when I was young and I get back scratches. I scratch my kids' back so they sleep on my belly too. Why do you hear that? What are you hearing? This is important. Come on, let's go. I don't want to move on. What are you hearing?
Stomach acid?
What?
The stomach acid?
Well, you're right that you're hearing the stomach. And yes, it does contain acid, but it also contains another key ingredient in addition to that acid. The reason that it makes a sound is not because it's acid per se, but because of something else in that stomach.
What?
Well, and the air. Do you all understand that, like this bottle, your stomach has a large air pocket? So watch. Carbon compounds, when oxygen is present, like in your stomach, make CO2. That's called aerobic digestion. And CO2 is not an energy source, it's not a fuel, that's just what happens on the surface. That's what burning is. That's why fires need oxygen. That's why gasoline, fuel-injected cars make CO2. That's why carburetors mix with gas, they make CO2. That's why you burn a bunch of forest fires and that makes CO2. Because oxygen, fire, mixing CO2. When you break carbon bonds with oxygen, you get CO2. But, here comes the farts. Your intestines don't have air bubbles normally. As a matter of fact, your intestines are pretty darn anaerobic. So the bacteria that lives in your stomach, there's no oxygen. In your intestines, there's no oxygen. That's anaerobic digestion. So all those carbons, they get broken down into methane. And the reason digestion came up in this unit is we use anaerobic digestion as a way to make methane. Landfills do this. Yes, it is true, cows do this. Cows do this. They make methane. Because after the first 1 or 2 stomachs, all their stuff goes to anaerobic digestion. They actually fart a lot. My favorite thing about the Santa Barbara wastewater treatment facility is after you deposit a deuce somewhere, your turd will like surf down the sewer system, and when they catch it, they're like, oh, sweet. And they put it in this big tank, and they heat it up and stir it. Peyton just barfed in her mouth. And when they stir it and they warm it up, all of your intestinal bacteria are like, oh yes, I'm in a big intestine. And they keep digesting all the stuff that was in your poo. And farts are made. And the Santa Barbara wastewater facility makes all of its electricity from burning the methane from all the farts that you didn't get to fart when you dropped the deuce that still had fart potential.
That's disgusting.
It smells really bad.
It does.
I've been there.
Yeah. Some parts of that facility smell really horrible. Well, we're gonna take a tour there in February. You'll love it. Yes.
Did they let you walk in the tanks? Because I've been there too many times and I've been inside a bunch of those things.
Yeah. So I have been there a bunch. A friend of mine is an operator there. So I think I've pretty much seen like a bazillion different parts. It's a really complicated system. There's a lot of steps. When you get a tour in February, it's a pretty glancing tour. I just need you to see like 3 or 4 things and then we leave. But if you ever want to go in depth, I've got some hookups there. You know, because I'm a local. I know people. I'm a big deal. I get tours of the fart machine. I was just hoping that somebody would bring up the digestion thing because you do need something for your notes. This is the right time to put this in there. Carbon compounds, aerobic CO2. Carbon compounds, anaerobic digestion, CH4. Burps, farts. Burps, farts. There's a lot of carbon compounds left in your poops. And your gut bacteria go to the wastewater treatment facility, and the anaerobic digest, make a bunch of methane, run the power plant. Sorry, run the wastewater plant. Okay. Other vocab? Yeah? Anthracite is one of the 4 grades of coal. Were you absent yesterday? I'm sorry our stream hasn't been working. I just got it fixed last night. So maybe somebody made a diagram that you can copy of the 4 different types of coal. It used to live right there, but I had to erase it because I'm planning another drawing. There you go, erase on it. Anybody else? It's the fanciest coal. It's the highest grade of coal. And then Maria will give you a diagram later that might help. Anybody else? Other vocabs? Okay, please look up. We're finally done with the non-renewables, which are the fossil fuels that run out. Non-renewable means it runs out. And now we're going to start talking about renewables, which don't run out. Like there is no limit to sunlight or wind, waves. Those are energy sources that you cannot use up. They are renewable. And boy, howdy, you're going to take a lot of notes in this one. I've got this crazy set of whiteboard illustrations. I have a key to remind myself of all the stuff I need to draw. And I will draw for you 29, 30, 31, 32, 33, 34, 35.
You want it in the fridge?
You.
You want it in the fridge?
Yes.
Okay.
If we're ready, I'd like to start with 29. You're going to need a whole bunch of drawings. Emily, thank you for doing that.
Yeah.
Okay, here we go. 29, 30, 31, 32, 33, 34, 35, I think, maybe even 36 are all the renewable energy sources. The College Board is going to expect you to understand how they work. I can explain all of them to you. I've got drawings planned for all of them. Today we start solar, Tuesday we finish solar, and then we move on to other renewables. You do need to explain solar panels. You probably don't want a copy yet. Please look up. Solar panels, traditionally, there's like a million different types of solar panels, but back in like the 1970s, original solar panels, please look up. 3 layers, silicon on top. Don't stress, I'll explain. A semi-permeable electrolyte membrane in the middle. I'll explain, don't worry. And a silicon layer in the bottom. Don't stress out, I'll explain all of these. How many of you speak chemistry a little bit? So, for those of you who speak chemistry, silicon, because it has 4 empty bonding sites, is really good to build like a 3-dimensional grid, a crystalline structure. Silicon makes like a 3-dimensional grid pattern when you glue it together, when you bond it together. Chemistry kids, you know what I mean by that? 4 bonding sites, so like a 3-dimensional grid. Okay. For those of you who don't know, please look up. The top and the bottom layers are silicon. It's a structural element. You have to know that it's silicon. This is not a trivia. And the top layer, layer number 1, also has boron added. That's element B. It's spelled B-O-R-O-N. Boron. So that's the little B's right there. There's the word boron in the top layer, number 1. The one that faces the sun, that's silicon with boron. Chemistry kids, there's probably an easy explanation for you. Please look up. Boron is important because 2p1, right? Like a single valence electron that's really excitable, it's barely there, right? 2p1. Chemistry kids? For those of you who don't have a strong chemistry background, no problem, write something next to the boron, like a little arrow. Boron has 1 loosely held electron. You have to know that. There's 1 electron that's just barely holding on to boron. You probably don't have to say that on the AP test, but it'll help you understand later, so please write that down. Silicon with boron. Boron has 1 loosely held electron. challenge with all of you, trying to convince the university that you've got university level environmental science, is you don't have university level chemistry. So for a chemistry kid, this is not a big deal. But if you haven't had chemistry, you need to take this Band-Aid. Boron has one loosely held electron. How many of you were in the room when we did the wave to signify electrical excitement? Where an atom's electron gets excited and then passes the excitement to the neighboring, okay. So here, where I'm gonna say moving electrons, that's just a cheap shot. What we mean is moving electron excitement, okay? Silicon with boron, silicon. Layer number 2 is that really big word, semi-permeable, electrolyte, membrane. That's 3 big words. You can abbreviate that, SEM. And I can explain what it means. It's easy. This is like a really cool trick of science. You can pick which electrical charges move through a substance. So semi-permeable semi-permeable means some stuff gets through. You know how like a lot of bars will hire a bouncer to only admit scantily clad women because that bar is trying to cater to predatory men, for example? That's semi-permeable, like the bouncer's being picky about who gets in. Jose shows up like, hi, I'd like to see the band. And the bouncer says, sorry bro, you're gross. Selective about who gets through. Semi-permeable. Electrolyte is picky because of which electrical charge? So a bouncer might only let in attractive young men or attractive young women or whatever. These membranes only let a certain charge move, like this. This particular one only lets negative charges go downward. You can make these any which way. Look. You can make positive charge right membranes, or you can make positive and negative charge up membranes, or you can make neutral either way membranes. They're just picky about which charge. But you have to know that in a solar panel, they're negative down. You have to know that in a solar panel, they're negative down. That's actually critical to this explanation. I'm ready to make electricity unless you have questions. If you have questions, please ask me now. Silicon with boron on top. Semi-permeable electrolyte membrane, negative down in the middle. Silicon at the bottom. Anybody want to ask me something? Because I'm about to make electricity. It just takes a second. Are we ready? Everybody good for this? Yeah? Watch. When the angry sun sends sunlight down to the solar panel, the boron loses its grasp on the electron. Like this. And electrons have a negative charge, so they're going to go where? Down, that's right. Because they have a negative charge, they're going to go down like this. Meaning, all of these electrons will migrate to the bottom. The boron is an electron donor in sunlight. Boron releases the electrons. If you're a physics nerd, boron passes electron excitement downward. Changes the energy level of the silicon if you're really nerding out here. So look what we've done. I've put a whole bunch of negative charges on the bottom. I took away electrons from the top, so I've left a positive charge at the other end. Children, what's a household item that you see often that has a plus on one side and a minus on the other? Bravo. In the presence of sunlight, the boron loses electrons or passes electron excitement to the bottom, which creates polarity. Now I can do work. If I connect those ends with a wire, just like plugging in a battery, those electrons will travel, light will be made, and as long as the sun keeps shining, I keep making electricity. Yeah.
So would the electrons pass through the light bulb and go back into the
Solar panel?
panel? Do they go through the borons again?
Yep. So they kind of like go back home to the boron, but boron still can't hold them. So they do the same thing over and over again. Now, remember that I'm using a really low-grade Band-Aid because some of my kids don't get the details. Technically, the electrons aren't traveling. It's their excitement which is traveling. Like that wave that we did, where like you pass a punch, it's like you get excited and you pass the punch. So it's not actually moving electrons, it's moving excitement. We will review this, but you did beautifully. Good job, thank you.